Hello there, this is Mr. Pekar, and we're going to be working on section 1.5, solving inequalities, so make sure you have that note sheet out. We're going to use this problem right here, talking about wireless plans and comparing them using inequalities, just simple inequalities. First of all, it says write an inequality to compare the price of plan 1 to the price of plan 2. Just looking at the monthly access fee, plan 1, it's $35. Plan 2, excuse me, it's $55. Well, if you're just not going to use a lot of minutes, 35 is less than 55. So that would be the better plan to go with. Now, there's another part to it though. Write inequality comparing the price of the additional minutes in plan 1 and also with plan 2. So when you get to additional minutes over your allotted amount, 400 minutes for plan 1 and 650 minutes for plan 2, you get into this, 40 cents and 35 cents per minute. Well, 40 cents is greater than 35 cents. So eventually, depending on how many minutes you use, plan 2 is going to be cheaper. But the lower amount of minutes, plan 2 would be cheaper. Let's look at number 3 here. Cootie knows that she will use no more than 400 minutes per month. Which plan is best for her? Well, if you use no more than 400 minutes per month, you're not going to worry about minutes included or the additional minutes. Definitely plan 1, which is $35, would be better than plan 2, which is $55 if you're only going to use 40 minutes. 35 would be less than the $55, so it would be cheaper. But if she uses 1,000 minutes per month, which plan is best for her? We'll say minutes, number of minutes used, that's going to be M. So if you use plan 1, that's going to be $35 to begin with, plus, I'll put a 0.40 here for 40 cents times M, the number of minutes, minus 400, because those first 400 minutes are part of the $35. So what it's actually going to cost is 35 plus 0.4 or 40 times 1,000 minutes minus 400. This is just one way to write it because she's going to use 1,000 minutes. $35 plus 0.4 times, this would be 1,000 minus 400 is 600. And finally, that's going to give me 35 plus 0.4 times the 600 is going to be 240. So total cost is going to be $275 if she uses 1,000 minutes. So what I want you guys to do, this is for plan 1. I want you to figure out how much it's going to cost for plan 2 over here somewhere, and then compare the two prices, which is going to be the best plan for this person. Okay, solving inequalities is just like solving equations, except one very important rule. That important rule is, it should be on your note sheet, if you multiply or divide by a negative number, you must reverse the inequality symbol. So anyway, we're going to skip number 5 and go right to number 6. And I'll let you guys do number 5. We'll do number 6 together here. You solve it just like an equation. Here's 7x. I want to get that variable term by itself, so I got to get rid of the 9 right here. I'm going to subtract 9 from both sides and end up with this 7x is greater than or equal to negative 21. Now, we subtracted 9. We didn't divide or multiply by the 9. or the negative 9 here, so we don't switch anything. Now we got to get rid of the 7. It's 7 times x, so we're going to divide, which is the opposite of multiplication, both sides by 7. These cancel out to 1, and I end up with x is greater than or equal to negative 3. That's my answer. Now I didn't flip. There's a negative 21 here, but we divided by a positive 7, so we don't flip it. If we would have divided both sides by a negative 7, then we'd reverse this inequality symbol and make it less than or equal to. Graphing solutions on a number line. Sometimes you graph your solutions on a number line. Use an open circle here. This open circle right here. If it's less than or equal to or greater than or equal to. You color it in when you're graphing on the number line. Use the filled circle or dot if it's less than or equal to or greater than or equal to. Right here. So if I was to get an answer, say, I don't know, x is less than 3. I'm going to graph it on the number line. Go right in the middle here, and I'll put the number 3 because that's part of my solution right here. And I'm just going to circle it. Less than means, think of numbers less than 3, that'd be 2, 1, 0. I'm going to shade to the left because that's all the numbers less than 3. Okay, so let's go back to our previous problem here. We solved this problem, and we got x is greater than or equal to negative 3. So negative 3 is part of the problem, or the solution, so I'm going to put a negative 3 right here. It's greater than or equal to now, so now negative 3 is part of the solution. So now we color it in. Think of a number greater than negative 3. There's negative 2, negative 1. 0 is greater than negative 3, so I would shade to the right. Okay, number 7 here. Let's try this one. It's a little bit more complicated, but you will see problems like this. Now, we want to solve for n in this problem. So I find my variable term 2n. I got to get that 2n by itself. So I got to get rid of the 5, the negative 6, and the 1 first. You kind of work on the outside and work your way in. I can't get rid of the negative 6 and the 5 because they're part of the fraction right now. So I'm going to get rid of the 1. I'm going to subtract 1 from both sides. That'll cancel these out, and I get 2n minus 6 all over 5 is greater than negative 1. Now, you might think you would add 6 to both sides, but that 6 is part of this great big fraction here. What I would do is get rid of the 5. You're dividing 2n minus 6 by 5, so if you multiply by 5 over 1, or multiply both sides by 5, these 5s will cancel out, giving us 2n minus 6 is greater than negative 5. Now, here's the 2n. Get that 2n by itself, so I'm going to add 6 to both sides. 2n is greater than 1. And finally, divide by 2. And we get the 2's cancel out to 1, and n is greater than 1/2. Now, we didn't divide by a negative number at all here, so we really don't change anything. If I want to graph this on the number line, I'm just going to put a little line there and say 1/2. I want to think of numbers that would make n a true solution. Those are numbers greater than 1/2. So I'm going to circle it, not coloring it in. 1, 2, 3. There's 1. There's 2. There's 3. All those numbers are greater than 1/2, so you would shade the number line to the right. Solving this one. I got negative 8n here. I want to get that by itself first. I'm going to subtract 14 from both sides. And I get negative 8n. Don't forget, if you're subtracting, that's a negative 8. It is less than or equal to negative 14. I'm going to divide both sides here by negative 8. And I end up with n. Now, I'm dividing both sides by a negative. So now I got to flip my inequality symbol to greater than or equal to? Negative 14 over negative 8. Well, a negative divided by a negative is a positive. So that means n is going to be greater than or equal to positive. I can reduce 14 and 8 both by 2, so that is 7 over 4. Or you could say n is greater than or equal to, if you divided it out, 7 divided by 4, 1.75. Graphing it on the number line, there's 0, 1, 2. 1.75 is right about here. It's greater than or equal to, so I'm going to circle it and color it in. N is greater than 1.75. Well, 2 is greater than 1.75, so we're going to go to the right. Write inequalities. Define a variable and write an inequality for the problem. Well, first of all, some keywords you're going to want to know when writing these inequalities. Is usually the equal sign, but when you put it with is less than, you get a less than symbol. And just the opposite is greater than. It's a greater than symbol. Also, is at most. That's less than or equal to. It could be at most $15. So could it be 16? No, it's got to be less than or equal to 15. Is at least is greater than or equal to. So we're going to break this problem up, number 9 here. Twice the sum of a number is no more than, that's the key right there, that's going to be our inequality, 3 times that same number increased by 11. We talk about a number here. I don't know what that number is, so I'll call it n. Here it talks about the same number. Well, that's also going to be n. They're talking about the same number. But let's go back to this. Is more than. Is more than, well, it's got to be, I'm sorry, is no more than. Is no more than has to be is no more than, less than, or equal to. So the first part, twice the sum. When you say twice the sum, you're going to multiply 2 times a sum. So we're going to put that in parentheses. Twice the sum of what? A number n5. N plus 5 is no more than 3 times that same number increased by 11. 3 times that same number, so it's going to be 3 times n increased by 11. And there's our inequality. I'm going to let you guys try number 10. We'll talk about that tomorrow, and we'll finish 11 and 12 in class also. Thank you very much.